Everyone, welcome back to SAT Math Question of the Day. Here's the question of the day. Please try it, pause the video, come back, and we'll try it here. Okay, here we have a radical expression. Which of the following is equivalent to the expression? So it looks like we need to simplify a radical, doesn't it?
Yeah.
So there's this rule that the radical A divided by radical B is radical A divided by B. So it makes sense to simplify this, doesn't it? Divided by 32, c to the fourth. So if you're really fast, you could probably already see the answer. But this is a quarter c to the 16th. So I'm just doing regular rules. So this is a square root of a quarter, square root of c to the 16th, which is a half c to the 8th. So if you're fast with this, you could probably see the answer immediately. If not, it doesn't take that much longer just to write it all down carefully so you don't make a stupid mistake. Did I make a stupid mistake?
I don't know. Did you? No, I don't think so.
I don't think so. It's not a great idea to simplify each radical on its own. That's do radical 8, radical c20, radical 32, radical c to the fourth. Let me write neatly for Seth.
Okay.
There you go. See, that's a pain to have to simplify radical 8 and radical 32. So.
Okay, great. So now, would you like me to ask do you want to respond to a challenge question to give our audience a strategic method?
A strategic method?
Yes.
A strategic.
No, what you did was you showed the follow your nose.
Yeah.
Follow your nose approach.
Right.
Making use of fundamental formulas.
Right.
For the context, right, and together with the fact that the square root of something m can be rewritten as m to the 1/2. Things like that. Those rules.
No, I didn't
together.
Do that. I didn't
Calculations of square roots of a quarter. Okay, that's follow your nose. Apply algebra. Now, strategic method for picking the SAT answer.
I know what you're going to say.
Without doing all the calculations.
Fine. I'm raising my hand.
Yeah.
Can you call at me, please?
Yeah, Joel.
Oh, thank
Brother
you.
Joel.
Thank you. Okay, I'll do it. Okay, I see what Seth's saying. Just look at the thing. C to the 20th divided by c to the 4th. Look at the choices. All the choices have a different c exponent, and they're not even close to each other. So you just do this thing. You just do c to the 20th divided by c to the 4th. That's c to the 16th. And the square root of c to the 16th is c to the 8th. You don't have to bother. You don't have to waste your time with the leading coefficients. You could just immediately see that the answer is c to the 8th just by looking at the c's. Is that what you were thinking?
Yes, you agree. We think alike.
We think alike, right? Yes, you are correct. That would have been faster. So a good thing to do on the SAT, which I did not do, but a good approach is to look at the answers first and look for patterns in the answers. Seth, thank you so much. That's absolutely right. If you want to save time, look for patterns in the answers and see if a pattern in the answer can help you do the question in half the time.
That's right.
Look for patterns in the answers. And this is a skill that you don't normally use in regular school. Because a lot of times you do not have multiple choice questions. Look for patterns in the answers to see. That's a little thick. I know it's that bothersome. To see if you can get the answer faster. And that overrides this, right?
Yeah. Together with the principal.
Yeah, together with the
that
principal.
SAT questions, unlike
I know.
real world
Yes, we
questions,
know, we know, we know, we
that
know.
well, let me say it again.
Go ahead.
One and only one of the choices is the correct one.
Right. Yeah. 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 Okay. But yes, you definitely have to know the square root. You have to know two exponent rules. You have to know that c to the 20th. No, you first have to know. Actually, yeah, you really should know that the square root of this thing. This is important to know. But even
Yeah,
if you didn't know it, you could certainly do the c to the square root of 20 divided by the square root of c to the fourth. And then
yeah,
you have to know the square root of c to the 20th is c to the 10th, and the square root of c to the fourth is c squared.
yeah,
Because you're looking for two numbers that multiply, two numbers that are the same, that when you multiply, you get c to the 20th. And that's c to the 10th. C to the 10th times c to the 10th is c to the 10 plus 10, which is c to the 20. So you do have to know the exponent. You do have to be familiar with the exponent rule to do this problem also. So
okay.
so review all the exponent rules and do as many exponent questions as you could find on Khan, and they'll give you a bunch of exponent questions. Anything else? I guess we should
Well,
move
we
the
just
answer.
could. Okay, okay, is there?
Yeah.
And again, we always pose. Uh, can a calculator be of any use?
Yep.
In other words, in other words, uh, or relatedly, is this a problem where it's a bad idea to use a calculator?
Yeah. It's calculate. You can use a calculator, but it would take you it would take you a long time to use a calculator.
It's a
Um,
bad idea to use a calculator with this.
yeah, 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 yeah. But you could. I mean, you never do this, but you could use brute force with a calculator. You can let C
Uh,
be 2, and then you can literally do the calculations. 8, no, but 2 to the 20th, the calculator will blow out. So that's not
yeah,
practical.
yeah,
That's not practical.
yeah.
Yeah, I
No,
mean
don't
that.
use a calculator.
Yeah, don't
That's
just don't even
because
take it to
the subject of SAT math includes algebra. All right? Algebra means that you do calculations with variables.
Yeah, yeah,
Variables appear as letters.
yeah, yeah,
And so a test SAT is a test your learning of math beyond arithmetic.
yeah,
Move the math that's introduced in middle school,
yeah,
where letters are objects that you manipulate by mathematical rules.
yeah. But I think they have calculators now where you could probably type this in, and then we'll let
Oh
calculators
yeah, yeah,
will
yeah,
handle
sure.
variables. But I don't think the calculator that they give you, which is the Desmos calculator, does that. And
Uh,
I don't think
it's
so.
absolutely it is not a matter of thinking. It's a fact that for quite a while calculators that did
Oh wait, that's it.
algebra calculations
Yeah,
were available, and they are used extensively by mathematicians and other users of algebra and mathematics. They're called, I don't know, they're called
yeah, 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 yeah.
symbolic calculators.
Okay, but it doesn't matter. You don't have that. You're not given it on the SAT. This is the Desmos
Yeah,
calculator. It doesn't simplify. It graphs it,
yeah,
but it doesn't simplify. Okay,
yeah.
enough said. Let's move on. So I think that yes, that was the answer. Okay, let's see how they do it. Uh, Great work. Okay, that's good. Let's see how they do it. Let's just keep getting all the hints. Oh,
Well,
goodness. Okay.
okay, that's cool.
Great, 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 great.
They indicate
Yeah.
they
Yeah, they do that.
possible
Yeah.
mistakes that lead to each of the wrong choices.
Yeah, but we don't normally go over that. Okay.
Okay,
So, they just look at how they do it. So that's
there
good.
you
They
go,
do the
Joe.
same exponent rule, and then they call that they bring in an exponent rule, x to the m divided by x to the n. They take the difference of the two exponents. That's good. Then they take the square root of c to the 16th. Okay, and then they get the answer. Yeah. Oh,
Okay,
look.
I want to give a criticism
Yeah. Okay.
of their statement. Okay, center on this.
Centered, centered, centered.
No, the general formula was the square root of x over y.
Oh yeah, sure.
Yeah, let me
Yeah.
say something about that.
Go ahead.
It says recall what they write. If the square root of x and the square root of y are real numbers,
Yeah.
that means x is a real number and y is a real number,
Yeah.
right? However, what's really happening is that the square root of x is a symbol. Well, it's a symbol, right? It's a
Yeah.
symbol where x is a symbol that might represent some uh, some particular real number.
Okay.
Okay,
Okay.
so we really the in the practice of algebra, this formula applies to symbolic expressions
Okay.
where x and y they're not particular real numbers. They are algebraic variables.
Yeah. Okay.
And in algebra, when you have an algebraic variable, it makes sense to give another expression that that applies an operation to an algebraic variable.
Okay.
And then when you do algebra, you apply this is a algebra calculation. You calculate the calculation of the square root of x squared is x.
Yeah.
Right? And this one calculation is one calculation that you as a person will do.
Yeah.
And this one calculation replaces the infinitely many calculations that are conceivable when x is replaced by some non-negative real number.
Okay.
So this is before algebra, you could only think of this property in terms of a particular real numbers.
Yeah.
And so
Seth,
so you might
what's your
say.
point? Seth, what is your point?
So the point is
Get to the point. Get to the point.
The point is it's more. I think it's more to the truth to say that square root of x and y are algebraic expressions.
Right. So what is Seth really talking about? Okay, let's get down.
What I'm really talking about
I know what
is that when you see problems like this,
yeah,
when you see formulas like that, you can apply them in terms of x and y.
Yeah.
That's number one.
Okay.
Number two is that when you have a formula like this, so point one is this actually is in terms of x and y. Number two is the principle of substitution. That you could combine this formula with a substitution where x is replaced by 8 times c to the 20th, and y is replaced by 32 times c to the 4th.
Right.
So what they did here was combine this rule with the substitution to get this conclusion.
Right.
And now that we have other algebraic expressions involving a variable named c, we can do algebra simplification.
Fine.
And the algebra simplification involves doing arithmetic, doing the arithmetic of multiplication and division on numbers that appear within the algebraic expressions.
Okay, fine. I think what Seth's saying, I don't know how many people, fine. Yeah, you're right. They should have said algebraic expression. Wait, I need to annotate. Right. Because I think in it, just to make a long story short, he's essentially saying that if you have some crazy thing like this, we have x squared plus 3x plus 92 plus pi over 8 squared divided by x squared plus 3x plus 92 plus pi over 8 regular. These things take the place of this x, this well, whatever. This is, you could manipulate these as if these are expressions. Okay, this whole thing is one expression. This whole thing is x, and this whole thing is x. So that's really x squared over x, which is just x, the square root of x. So these
where your yellow x. Yellow x is different from the
That's right.
Blue
but
x.
The idea is that these represent more than just little numbers or even simple expressions, relatively simple expressions. This x and this y can be crazily complicated, and that's okay. And that, you're right. That is overlooked. That is overlooked and not emphasized enough. And when people see things that are crazy, and they're just one crazy number, but the same crazy number is on the top and the bottom, you get like freak out. And it should be, yes, you're right, it should be discussed that these are expressions. These aren't just single numbers or even simple things. They can be crazily complicated.
Well, I wonder, this leads me to think that a shortcoming of the use of calculators in teaching arithmetic is that the rules of arithmetic translate into the rules of algebra. So when kids learn to do arithmetic with a calculator, they do not get much practice with the rules of arithmetic.
Right. Yeah.
And then when they are taught algebra, they have to learn the rules of algebra and become skilled in using the rules of algebra without having grown up with the skills in using the rules of arithmetic.
Yeah.
And so the use of calculators for teaching and applying arithmetic leaves students unprepared for using the rules of algebra.
Right. Right.
Now, I th- the no a possibility, and some educators might propose or actually teach that the rules of applying the rules of algebra is not such a big deal, is not such an important skill anymore, because we now have computers that do calculations in algebra uh, internally and quickly and correctly, just like the arithmetic calculations, do the calculations of arithmetic.
Right. Yeah. But
So one might ask, well, then why? What's the point? Why burden middle and high school students with learning the skill of using the rules of algebra when they could use an algebra calculator, a symbolic calculator?
Yeah, but come on. You know, people, in order to learn, no one's going to sit there and know how to use a symbolic calculator unless they're going to use it for like science or calculation. So,
well, things move down. People, things that are. It used to be that calculators were available only to scientists and engineers, so now every kid has a calculator.
But if you in order to use a calculator, you have to know what 3 means, right? If you use a symbolic calculator, you have to know what 3x means. And don't forget, you learn what 3 is because you go from preschool to 7th grade. You learn what 3 is. How are you going to know what 3x is unless you learn what 3x is? You're not going to just grow up knowing what 3x means on your calculator. But you.
Well, I think one of the problems in education is that too many people don't know what 3 times 4 means.
Yeah. Okay.
They confuse 3 times 4 with 3 plus 4.
Yeah. Okay. Well, that's a whole other issue. Okay.
Well, the thing is, 3 times 4 plays the role in arithmetic as, say, 3 times x or y times x plays in algebra.
Right. Yeah. Okay. I think we're done.
We're done. We philosophize here.
Yeah, no philosophizing. Let's just
did we introduce ourselves? I don't think so.
Not yet. Do you want to?
Okay, so let's introduce ourselves and then go away.
Absolutely. Let's fade off. Let's fade off as quickly as possible. Okay, so I'm Joel. I have a PhD in mechanical engineering from Columbia University, and Brother Seth here, PhD from MIT in math. And Seth's been a professor emeritus professor at computer science. Seth's been a professor teaching computer science at City Albany for many years. He is now retired. He's a professor emeritus. We're here to hopefully show you different approaches on how to do math SAT questions to prepare you, hopefully, for the math SAT. We offer very often different approaches. We're brothers, but we also think differently, thank God. And that's what we will offer everyone, hopefully. And the approach we do agree on is to go to Khan Academy. They offer 600 or 700 math questions that are sanctioned by the math SAT people, the College Board. They basically tell you exactly what's on the test. You learn all the topics from Khan Academy. You practice. Then you go to the math SAT. Then you go to the SAT website, take as many of their practice tests as you can, and that should adequately prepare you for the math SAT. We try to meet daily, and if you have any SAT, please dislike our videos, comments, or we strongly encourage comments. We take them very seriously. And if you have any SAT math questions, feel free to email them to us at satmathquestionoftheday@gmail.com. That's our boilerplate. We always do that at the end if anyone has survived this late in the video. Okay, that's it, right?
That's right.
That's it. Okay.
Goodbye.
Hopefully see you tomorrow.